Thank you, Tim Kraska and the team at Einblick for putting together this event. I'm super excited to be speaking here at the first ever Citizen Data Science Summit. So we're starting to recover from the depths of 2020. So I've been looking at job postings at the key technology metro areas in the US. This includes places like the San Francisco Bay Area, Boston, New York, Austin, and several other places. So I look at job descriptions and I look at the occurrence of key phrases. So as you can see, the phrases that we normally associate with data scientists are starting to grow again in terms of number of job openings. And if you look at related areas like Python, so Python is the most popular programming language for data scientists, and distributed computing, they are also growing strongly as well. And as many of you know, data scientist is now one of the hot fields or hot roles in IT. So this is data from Glassdoor, and this is similar data from Stack Overflow. And you can see that while data scientist is compared to these other technical roles is a lot younger, it's already comparable to the more established developer roles out there today in terms of compensation. So before I point out areas where citizen data scientists can make an impact, let me go through where we stand as far as the role of the data scientist today. So I was part of the first cohort of people who really started coalescing around the term data scientist. This would be the late aughts. And as I recollect and I look at what we were doing back then, right? So we were really kind of held back a lot by what our tools could do, right? So particularly at scale. So this particular quote is quite representative of what I would hear when I would attend some of the first data science conferences in the early 2010s, right? So basically people were really focused on the basics and being able to execute on the basics. So let's look at what's happening today. So again, this is a year's worth of job descriptions for data scientists. So as the tools have gotten better and easier to use, the expectations have changed. So data scientists are now more likely to be expected to take on more challenging projects and tasks, including machine learning. So we started out back in the 2010s focused on structured data and basic analysis like BI and analytics. And today, we're more likely to use a variety of data types, particularly text. I think most data scientists work at companies that handle a lot of text. And more importantly, the level of analysis we're expected to deliver has increased as well, right? So you're expected now to be able to do machine learning, increasingly simulations. So for example, Einblick is a fantastic tool because one of the things it can do is help you run through what-if scenarios in simulation. And the other thing that's changed is that the data scientists are also expected to know a little more on the data side, data processing, building their own pipelines. So I've talked to a few data science leaders who say that they expect their data scientists to build their own pipelines these days. And data scientists are also expected to be familiar with many more data systems compared to back in the early days. So the bottom line is companies who want to build high-performing data science and machine learning teams need to have a variety of tools and probably a variety of roles, specialized roles. So you now hear about machine learning engineers. I'm increasingly starting to hear about data ops engineers and even ML ops engineers. So, but the long-term trend is in technology is tools will become easier to use. And as tools become easier to use, I expect the citizen data scientists to be able to contribute to many aspects of data science and data engineering as well. So if you're a citizen data scientist, what areas should you focus on to increase your impact? So before I answer that question, I'd like to just establish that we have two upcoming surveys that are about to be released, and I will be drawing upon these surveys. So one is focused on NLP. There we were able to ask more questions on the modeling and machine learning side of things. The other surveys focus on data engineering, so we are able to ask more data-centric related questions. So the first trend is the cloud, right? So we asked people, where do you store your data for BI analytics and data science? And as you can see today, over a third are already 100% cloud-based. In a year or two, about half of them will be 100% cloud-based. But it's actually more than being cloud-based. A lot of companies are increasingly multi-cloud. And by multi-cloud, this could mean any combination of the public cloud platforms or combinations of a public cloud platform and a private cloud. The other trend is that talent wars are becoming fiercer than ever. So companies are wanting to expand their talent pool. And so one way for them to do that is to train their own employees. But I think one implication for this as well is that I expect the tools to get better and easier to use, because that's another clear way for companies to expand their talent pool. And I think the cloud also will help in this aspect, right? Because as companies become more open to using the cloud for data science and machine learning, that means we will have more vendors who will build tools for the clouds. And software as a service vendors by nature can iterate faster. So we will see better tools and easier to use tools, I think, in a much more compressed timeline than ever. So for companies who want to expand their talent pool today, what are their options, right? So the first option is to literally teach their people how to code, right? So they can do that by organizing their own coding classes or bringing in trainers or giving their employees access to any one of several online learning platforms. The other option is to start looking into low-code tools. So low-code tools came out of companies' desire to increase the productivity of their workers. So the idea is to have tools that will allow your developers to accelerate their test, learn, deploy process. So there are several forms of low-code tools. So the first form is visual programming. So here you have mostly a graphical user interface with some coding. The other is a declarative interface. So people who work in machine learning who've encountered any one of these AutoML tools might be familiar with the declarative interface. So there, for example, you have data and you tell the AutoML tool, here's the model I want built using my data. And the more recent examples are these coding assistants that are built on top of these large language models. So the coding assistants are meant to eliminate a lot of kind of the routine coding work so that developers can focus on the more challenging aspects of their projects. So going beyond low code, there's also a set of tools for no code. So great manifestation of no code is for the tools for building websites. So let's say you want to build a website using WordPress. You can do that today without writing any code. But the interesting thing about WordPress is that you can actually build very sophisticated websites because WordPress has this massive ecosystem of plugins, right? So where you can add more complex functionality to your basic website. So the reason I bring up no-code is that I'm beginning to see no-code in the areas that we're interested in for this conference, right? So for example, we're beginning to see low-code tools for extracting and loading data, no-code databases like Airtable. And when it comes to analysis, we have plenty of options there, including Einblick. So Einblick is a fantastic tool because you can do a little bit of your data prep, but a little bit of your BI, but increasingly, as I mentioned earlier, machine learning and even simulations. So years of surveys have surfaced the following areas of concern for companies when it comes to modeling. So these are the challenges and their key criteria for when they evaluate solutions. So I can't cover all of them, but let me cover a few of them, starting with scale. So the scenario for me is as follows, right? I have a laptop and I have a nice setup on my laptop. I have all the Python libraries I want. They work well. I've spent time painstakingly installing the things that I want. It's all working well, right? So, and I imagine citizen data scientists have the same situation, right? So they have a laptop. They work with a suite of tools on their laptop. But in both cases, every now and then we do want to burst out to a cluster, right? So for whatever reason, right? So we're working with more data, or we want to run more machine learning experiments, so we want more compute. So the good news is I can do that today using an open source project, Ray. So with Ray, I can take the exact same work I have on my laptop, same code, add 2 lines of code, and boom, I'm on a cluster. And I think the interesting thing about this is that over time, I think we'll see this also manifest itself in the tool set for citizen data scientists, right? So where they are perfectly happy to work on their laptop most of the time, but every now and then they want to burst out to the cloud. And tools like Ray will easily be able to help their tools transition to a much bigger cluster. So we spend a lot of time talking about models as a community, but the reality is there are many tools today that will get you to, in many cases, decent baseline model, right? So these are the AutoML tools or tools like Einblick. But when we survey companies about machine learning, so one of the things they keep bringing up is the ability to tune models. So for example, in NLP, actually, we have an abundance of models, right? So there's so many embeddings to choose from. But chances are, depending on your requirements, so these models may not be sufficient for your needs, right? So they may work off the shelf, but maybe not as accurately as you will want in order to deploy, right? So imagine a scenario in NLP as follows, right? So you have a language model that works in health insurance, but your domain is cancer research or oncology, right? So how do I take that baseline model and make it better? So the good news is that there are now tools that allow a citizen data scientist to do this fine tuning, right? So I see this mostly in natural language processing, so text data and computer vision. So the workflow is as follows, right? So you have a baseline model, and you have a nice data annotation tool where your citizen data scientist or domain expert can annotate some examples that are specific to your domain or use case. And then you iteratively improve your model using this platform that you're using, right? So most of these platforms are no code, by the way. The other scenario that I've encountered when it comes to model accuracy and fine-tuning models is the situation with not enough data, right? So I think most of us talk a lot about big data, but sometimes we forget situations where there simply isn't enough data, right? So imagine building a predictive maintenance model for a piece of equipment where the amount of failures is really quite rare, right? So this actually happens in industrial situations. You have refrigeration equipment or air conditioning or heating, right? So those are highly reliable equipment, and sometimes you just don't have enough examples to build your baseline model. So in those scenarios, what you need is a tool that can help you combine domain knowledge and machine learning in a principled way. And by that I mean maybe you take domain knowledge and use it a lot in the beginning, and then over time you transition more and more and rely more and more on your machine learning model. So the good news is there is an open source project that allows you to do this. It's called hfirst.ai. Right now it's primarily aimed at developers, but I think as the open source project matures, I can imagine scenarios where citizen data scientists can take on the role of building these blended models of domain knowledge and machine learning. Another area that I'm increasingly hearing about is testing models, right? So the idea here is that the community of ML practitioners, they want to take the lessons from software engineering. How do we inject more software engineering rigor into how we build, test, and deploy machine learning? So how do we build unit tests for machine learning? So we are starting to see an initial set of tools, and a lot of these tools, actually, the tools I've seen in computer vision and natural language processing, they're all accessible to citizen data scientists, honestly. So this is an area actually where a citizen data scientist can make an impact today. So we talk a lot about models as a community, but as you all know, data is an important aspect of what we do, right? So when we surveyed data engineers and data architects, these are the key challenges that they identified for us. And so I don't have time to cover all of them, so let me talk a little bit about data quality for a second. Before I do that, you may ask, so why focus on aspects of data engineering at all? Well, I'm sure you've seen versions of the following slide, right? Where, and this particular slide is inspired by a recent talk by Andrew Ng, where he surveyed studies in industrial AI. So basically, the idea behind these studies is that they all show that focusing on data is more impactful than focusing on tweaking your model, right? So if you're a citizen data scientist wanting to make an impact, it's important for you to be aware of the tools out there for doing data work. So as I mentioned, data quality is a high-level concern for companies today. So it's no surprise that when you try to look at this data quality space, there's now many startups that have come out over the last few years. Startups and open source projects, right? So again, the good news here is that there are already tools that will allow citizen data scientists to do data quality work. And again, go back to that slide from Andrew Ng, right? So data work is high impact work. So make sure that you're familiar with some of the basic tools for doing work on the data side, particularly data quality. So there are now tools both for structured data and computer vision for doing data quality kind of work that a citizen data scientist can do. And in fact, OpenRefine, I keep encountering OpenRefine, particularly in a subset of citizen data scientists. Data journalists use OpenRefine quite a bit. So, as a citizen data scientist, you need to also be able to acquire your own data. So be familiar with some of these new tools for doing your own data acquisition, right? So extracting and loading data. But going beyond just extracting and loading data, as I mentioned earlier, data scientists, also citizen data scientists, should also be able to build their own end-to-end data pipelines, and maybe all the way to basic data applications or prototypes, at least, of data applications, right? So the more you are familiar with some of these tools for building pipelines, and increasingly many of these tools are accessible to citizen data scientists, the more impact you're likely to have. So let me close by with a few thoughts. The first is on managing risks. So as companies build and deploy more machine learning and AI, they're increasingly cognizant that they need to manage risks. So responsible AI, it seems like the consensus term that people are using to collect many of these risks, right? So I don't have time to talk about all of them, but let me give you a few quick thoughts about fairness, which is one aspect that we hear a lot about, right? So, and while we hear a lot about fairness, it turns out that most companies are actually still not doing much in terms of fair ML, right? So this is from a recent ethnographic study, so a 2020 ethnographic study with 26 respondents from 19 companies, right? So if you're a citizen data scientist, you want to make an impact, this is an area where you can probably start nudging your company, right? So what are we doing in terms of fair ML? But then once you go down that path, you have to have a plan. So BNH.ai is a new law firm focused on helping companies mitigate risks pertaining to AI. So they are a law firm, so they are the people that your chief legal counsel will call when something happens to your model. So B&H is not only talks to chief legal counsels, they also talk to data teams, and they're also starting to talk to management consulting companies as well as government agencies like NIST. And what they found when they talked to a variety of folks is that one area where companies can really make an impact or really get started in terms of responsible AI and fairness in ML is just improving their documentation, right? So have a formal process for documenting your models and your data. So if you're a citizen data scientist, you want to make an impact, get your company to take documentation more seriously. So this is a great time to be a data scientist and a citizen data scientist. So I have good news. Two of my friends just wrote a book, The First Career Guide for Data Scientists. So this is a book that you should read whatever stage you are in your career. So they have content for people who are just getting started in their data science career, all the way to people who are leading big data teams. So as I mentioned, we have 2 surveys coming out, but we're also about to release a list of the top places to work for data scientists. So the best way to find out when this material will come out is to subscribe to our newsletter, which you can find at gradientflow.com/subscribe. Thanks for your patience and for your attention. And thanks again to Tim Kraska and the team at Einblick for organizing this much needed and important conference. I hope you enjoy the rest of the conference.